Hello, and welcome to my third project for MA 3210, Design and Manufacturing, taught by Dr. Hassan Rashidi at Georgia Tech. My name is Declan Campbell, and today I'll be talking about five manufacturing processes and techniques that I'll be highlighting. So to start things off with lean manufacturing, one of the first people to propose lean manufacturing was Benjamin Franklin. In the 1700s, he stated that reducing unnecessary costs was more of a priority than attracting new customers and expanding your business. Some businessmen in the 20th century, like Henry Ford and Frederick Taylor, both used these concepts as well. And then some researchers at Toyota kind of pioneered and established the origins of lean manufacturing. In the middle of the 20th century, Womack and Jones defined lean manufacturing as a way to do more and more with less and less human effort, less equipment, less time, and less space, while still delivering to customers at the same value. So one of the first focuses of lean manufacturing is minimizing waste while still keeping your same value and productivity. So the first step is to identify these sources of value and to utilize a value stream mapping, basically looking at where your value comes from, and all the steps and information streams that allow you to deliver that value to the customer, and then optimizing each step of the process across the product's entire life cycle. Another important thing to do is establish a pull system, which basically means that you're reacting to consumer demand instead of being proactive. So this allows you more flexibility, or it requires a lot of flexibility, but has a lot of upside, like reducing the inventory costs that you need, as well as um, reducing the amount of waste that you produce by not overproducing. The last step after this is perfection, which never reached, but approached by continuously iterating and improving your process. So lean manufacturing can be a great way to increase the profit lines and profit of the business, and also be more environmentally friendly. I was really drawn towards it because of the efficiency and iterative improvement that is involved with it. There are some drawbacks to consider, like included stress on employees due to these fine margins and less room for error. It can also lead to less emphasis on further development and research if you're so concerned with getting rid of waste and things like that. It can also lead to supply chain disruptions, like similar to just-in-time manufacturing methods. The next method I'd like to talk about is electrochemical machining. It was first proposed by a scientist in 1929, but really started to gain popularity in the 1950s. It's a contactless process with no heat input, no real contact. So things like mechanical wear, thermal stress, all those problems are avoided. So that's very useful. But one drawback is the material must be conductive in order for the process to work. So the tool functions as the cathode, and the workpiece is the anode. You plug in the tool to a constant voltage source, and then there's an electrical chemical reaction with a charge exchange taking place in an electrolytic solution that can only target localized specific spots of the workpiece. Then, as a precipitate of this reaction, the material that's removed comes out as metal hydroxide. So allows for highly complex features to be machined with very high surface quality, which is a very big pro. And it can also give you very high precision tolerance. And you can also really dial in your material removal rate by modifying these parameters, electrical parameters, and the pulse characteristics. There are some disadvantages though. It can only be used on conductive materials, like I said. There can be high setup costs, and you also need to deal with the disposing of the electrolyte solutions in an environmentally friendly manner, and the tool can also corrode. But it's seen great success in certain industries like in aerospace, machining the metal turbine blades, pin turbines, as well as the medical and automotive industries. The next method I want to talk about is concurrent engineering, which is basically the process of where you kind of integrate the design and manufacturing engineering that goes into a product into one seamless process under the same roof. So it can greatly make your process cheaper and reduce your costs, and make it the process go much quicker, preventing miscommunication, removing any barriers between the two teams. As you can see in this diagram, instead of like each step of the process coming one after the other, they can kind of overlap into one smoother process. And the manufacturing team can make choices ahead of time and provide feedback to the design team if they want any changes, and you consider the entire life cycle of the product. It does require effective data sharing through product data, through a product data management system, so that everyone's on the same page, working on the same data. This become very popular in industry. Toyota and NASA use it to create success, but it does have a lot of drawbacks to consider. There's a lot of complexity in planning, organizational challenges, a lot of chance of error. So it really needs effective leadership in order to be implemented properly. But if you can implement it properly, it can be a really good way to increase your innovation and reduce the costs and lead times that your product have. The next method is ultrasonic machining. Basically, in this method, the tip of the tool vibrates. It's called the synectrode, with very high frequency, up to like 20 kilohertz, at very low amplitude distances, usually around like tenths of a millimeter or so. So it uses, as you can see this diagram, there's this oscillator which drives the periodic input of the stroke of the tool, and it uses this abrasive slurry that basically removes the material and carries out the debris. So it's a very good method for materials like glass and ceramics. There's also an alternative. Instead of the abrasive slurry, using a rotating like diamond tool that can be much better at producing deep holes. Similar to electrochemical machining, it also has like no thermal stress, so it's a good way to use on materials that are sensitive to heat, and you can really create very complex shapes with tight tolerances and high precision. One drawback is the material rate tends to be pretty slow, especially considering the amount of energy used to remove that little amount of material. The standard method with a slurry often has a tough time digging deep holes. You can only really use it on like harder materials in order for them not to be damaged, and it also needs to be like replaced and maintained a ledge because of the kind of intensity of the contact between the two parts. But it's been used in a variety of industries like medical and aerospace, and because of how precise you can produce parts, it's a very good method for transistor manufacturing because transistors have gotten smaller and smaller. But overall, it's a great way to machine high precision, complex features, and you can't really distort the workpiece at all with this method. The last method I wanted to talk about was 3D printing, also called additive manufacturing in like manufacturing in industrial terms. It's a great alternative to typical subtractive methods where you take a stock piece of material, then mold, form it, cut it into like a desired shape. You're basically kind of building it from the ground up, layer by layer, and you can really like customize the geometry and shape that you want. One great benefit of it as well is that you can very easily go from a 3D modeling or like CAD software and quickly produce like a 3D printed prototype. Usually use like a plastic or polymer. There's also been methods developed to use metal in like a powder form that can be made into a fully metal part. So it has a lot of promise in a variety of industries like aerospace and energy. One great industry it's been used in is the medical industry, just because of how customizable and like with you can get really unique shapes and designs, and also like prints with very biocompatible materials that can be used in like transplants. So that works very well in the medical industry. There's a lot of drawbacks to consider as well. You often need like a lot of post-processing, like operations on the part after printing it. Not a lot of materials to use, and it can also be like very energy intensive. But overall, like the design freedom you get and the ability to produce quick prototypes at an effective cost will make it a very exciting option moving forward in manufacturing. Here are the resources I used. I used a lot of lecture slide notes as well as our textbook, and I did a lot of research online with various articles on each method. Thank you for watching.